Today we're going to look at the standard algorithm, but we're going to do so based on your knowledge of partial quotients. So if you know the partial quotient strategy for dividing large numbers, then it's just an easy jump over to the standard algorithm. First, I'd like to invite you to just pause the video and take a look at the difference between these. See if you can figure out what's happening in the standard algorithm that's different than partial quotients, and I'll be back in a second after you pause. All right, let's run through this standard algorithm on the next page. So I have the partial quotients beside us so we can see how the standard algorithm is similar to partial quotients. So the first step in the partial quotients strategy is to see how many eights can fit in the entire dividend, 3,480. And I found that 400 eights can fit into 3,480, and that would make 3,200. The standard algorithm, it's a little easier than that. It's a little bit more abstract, but instead of looking at the entire dividend at once, you just get to go digit by digit. So can I divide the 3,000s by 8? Well, no, 8 is larger than 3. Can I divide the 3,400s by the 8? Yes, I can. If I count by 8s, 8, 16, 24, 32. So I can get as close as 32. So, of course, this is actually 32 hundreds because I'm in the hundreds place. And that's what we found in the first step over here. So it's the same thing, except in the standard algorithm, you don't worry about these other place values behind yet. So right now I found that I can get 32 hundreds and 34 hundreds. So where do I place the quotient? Well, the place value is so important. That's why I'm using this grid paper. Since I'm working in the hundreds place right now, 4 eighths are 32. So I'm going to put the 4 in the quotient in the hundreds place. So it's very important that you put the quotient in the correct place value. Okay, so what's next? Well, I'm going to subtract just like I did over here. 34 minus 32 gives me 2. So now I have 2 hundreds left to divide, but I still have a little bit more in my dividend. So what do I do here? Well, I'm just going to bring down the digit in the next place value, because remember, I'm just going place value by place value in the standard algorithm. I'm going to bring that down here. Now I've got 28 tens left to divide. Look how similar that is. 28 tens, it's the same thing as 280. I'm just going digit by digit. So I don't look at it as 280. I'm just looking at it as 28. It's a little bit easier to look at it that way. So now 28 tens, can 8 divide into 28 tens? Well, yes, it can. 8, 16, 24, that's 3 eighths, makes 24. So I'm just looking at it as 24 tens, but since it's 24 tens, we put that quotient in the tens place in the quotient, so that's 3. Again, 3 groups of 8 is 24. So now I just subtract, just like I subtracted over here the partial quotients, but I don't even have to think of it as a 3-digit number. I'm just thinking of it as a 2-digit number. 28 minus 24, 4. So I have 4 tens left to divide, but I'm not done with my dividend. I have a 0 in the ones place. So I'm going to combine that 0 in the ones place with this 4 in the tens place, and I have 40 left to divide my entire dividend, just like over here. So here, this is exactly like partial quotients. How many 8s fit into 40? Well, 5 of them. And so the 5 goes in the ones place because that's the place I finally reached in my dividend. And I don't have a remainder here because 40 minus 40 gets me right to 0, and 435 is my quotient. Let's look at another example. This time we've got a 2-digit divisor, which works just the same as a 1-digit divisor. It just might be a little more difficult for you to count by this divisor. We've got a 5-digit dividend. So now I don't have partial quotients for you to look at. We're just going to go standard algorithm here. So standard algorithm, we're just going to go digit by digit in the dividend. How many 34s can fit in 4? None. 34 is too large. So I move over to the next place value, now the thousands place, and 1 34 can fit into 40. 1 34 is 34. I'm working in the thousands place right now, so I'm going to put that quotient up in the thousands place. One group of 34 is 34. Now I just subtract. 40 minus 34 is 6. And now I'm on to the next place value, the hundreds place. There's a 9 in the hundreds place. So I'm going to add that 9 with the 6,000s here. And now I have 69 hundreds. So can 34 fit into 69? It can. 34, and then 34 plus 34 is 68. So that's two 34s. Two 34s. I'm in the hundreds place, so I put two 34s there. Two 34s is 68. I just subtract that. I have 100 that I still have left to divide. Let's go to the next place value in the dividend. It's a 3. So I'm going to bring this 3 down. And 34 cannot go into 13. So this is a common issue people who are learning this algorithm have, is that they think, oh, it can't go into 13, let me just move to the next place value. That is going to mess up your quotient. So when you get to a place where the divisor will not fit in to what you have left to divide, you have to put a 0 in that place value. Because if you don't, we would get a 3-digit quotient, and that's completely off. We're gonna get a 4-digit quotient here, so we have to put that 0 there to hold that place in the tens place. So 0 34s is 0, right? So I still have 100, 3 tens, and 1 6 to divide. Okay, so now I got to my last place value, 136 divided by 34. How many 34s would fit into 136? So I've got to do a little bit of math here. So 34, and then 34 plus 34 is 68. Okay, another 34. 8 plus 4 would be 12. 3 plus 6 is 9, but I have to carry that. So 102. 102 plus another 34. 2 plus 4 is 6 ones, and 10 plus 3, that would be 13. So 136, perfect. So that was 1, 2, 3, 4 34s. 4 34s makes 136. And again, we've got a situation where we have no remainder. So that's 1,204. Again, I'll just draw your attention. If we didn't put that 0 here when 34 couldn't fit into 13, we would have got 124 for our quotient, and that's way off. You've got to put that 0 in when your divisor cannot fit into the number that you're dividing. So there you go. Go ahead and rewatch this video if you need to see anything again, maybe work through a problem with me, and good luck. It takes a little bit of practice, but you'll get these steps down.